This is lab number 1, and I'm Obi Nwosu. So to introduce the lab, we want to observe the motion of an object that is moving at the same speed without changing direction. And we discovered that the motion of the object in real life does correspond to the motion described using the laws of physics. So I decided to observe the motion of my soccer ball, and we're going to record a video of the soccer ball's motion, analyze it using Tracker, and compare it to a computational model. For the system, it's the soccer ball, and the surrounding, we describe that as everything else. And so for some extra information, for an object to move with a constant velocity, net force on the object must be equal to 0. And the motion of the object is constant due to the law of inertia. So since we are dealing with the object with constant velocity, our most useful and applicable formula is the final position of the ball is equal to the initial x position of the ball plus velocity times delta t. So I'm filming the video, we need something to roll at constant velocity, and I chose my soccer ball. And the path of the motion of the ball needs to be perpendicular to the camera for Tracker to accurately analyze it. The initial conditions, we assume that the ball is placed at x equals 0, and the final position of the ball is at x equals 1.6 meters. Creating a computational model, basically I use the starter code. I changed the maximum time to 0.7 seconds, as that is the total duration of the ball's movement. And I assigned a time interval to 0.1 seconds where the ball is updated every 0.1 seconds and the ball moves an additional 0.229 meters every second. This computational model is going to be a great basis of the motion described by the laws of physics with this equation, and the law of inertia accurately describes this motion as there are no forces acting on the object. So then we track the motion using Tracker. We uploaded the video to Tracker, and we aligned the horizontal axis with the path of the ball because the camera is slightly tilted, which means that the ball's Tracker would analyze the ball's motion as having a vertical component, which we know is not true in real life. So then we placed the tracking points, and Tracker gave us a set of positions and times and created this graph using the data set. And here, comparing the two data sets from the computational model and the Tracker, we can see that the two data sets are very similar. The x position varies directly with time in both data sets, and we can see that the velocity is constant and there's no acceleration. There's only a slight discrepancy between the two data sets, and we can address that in the following slide. So potential errors, we could say that there are inaccurate position markers by using Tracker. The horizontal axis could be not perfectly aligned, or the camera dimensions and distance calibration could be not fully accurate, and this is all just due to human error. Also, we made assumptions that there are no external forces acting on the ball like friction and air resistance, and we just considered that negligible for the sake of the experiment, when we know that this actually exists in real life. So some questions we should address. If we flip the axis of the ball's motion, the displacement and the velocity would both be negative, as they would technically be going in the opposite direction. However, the magnitude of the velocity would still be the same. All that changes is the direction, which is arbitrary. We can consider the direction to be whatever we want. And is it possible to know how many forces are acting on the object? No, because there are so many forces that are acting on that object, and unless we restrict our surroundings, it's impossible to list them all. There are different objects such as gravitational, wind, air resistance, friction, and so on. Conclusions. We describe that the motion of an object with constant velocity observed in real life corresponds to the motion described using the laws of physics. The motion of an object with a constant velocity can be described using the equation x final position is equal to x initial position plus velocity times delta t. This is because there's no net force on the object and there's no acceleration on the object. Therefore, the object will have a constant velocity and continue to move as it was as described by the law of inertia.